Hi, this is Alex from devstories.eu. LangGraph, episode 10 of 18. Your workflow processes a payment, hits a rate limit on the next step, and crashes. When the system recovers and resumes the workflow, your customer gets billed a second time. Your code did not change, but the assumption you made about how the graph resumes was wrong. The fix requires understanding durable execution and idempotency. Many developers assume that when a long-running process pauses or fails, resuming it picks up from the exact line of Python code where it stopped. They expect the runtime to magically remember local variables mid-function. That is not what happens. LangGraph does not freeze the Python interpreter in place. State is only saved at the boundaries between nodes. Durable execution in LangGraph means the system tracks your progress by persisting the graph state after a node finishes its work and returns. If a node fails halfway through its logic, the system has no record of its partial progress. The last known good state is the one passed into the node when it started. When you restart or retry the graph, execution resumes by rerunning that entire failed node from its very first line. Think about the payment scenario. Suppose you write a single node that performs two actions. First, it calls an external API to charge a credit card. Second, it updates a remote database to record the transaction. The credit card charge succeeds, but the database connection times out, causing the node to crash. The graph state does not advance. When the workflow resumes, it passes the old state back into that same node. The node starts over. It hits the external API and charges the credit card a second time. Here is the key insight. Because nodes can restart from the beginning, any side effect inside a node must be idempotent. Idempotency is a property where executing an operation multiple times yields the exact same result as executing it once. If your node interacts with the outside world, you have to write the code assuming it will run multiple times for the same step. How do you ensure this safety? You have two practical approaches. The first is leveraging idempotency keys with your external services. When you call the payment API, you pass a unique identifier derived from the current graph state. If the node crashes and reruns, it sends the same unique identifier. The external service recognizes the duplicate request and returns a success response without actually moving money again. The second approach is structural graph design. If a specific operation is not natively idempotent, do not group it with other steps that might fail. Put the dangerous operation inside its own dedicated node. Make it the only thing that node does. If you put the payment charge in node A and the database update in node B, a database timeout only crashes node B. The graph resumes at node B. The payment charge in node A is completely safe because node A finished and the graph saved its state before moving forward. You control where the system saves its progress by how you draw your node boundaries. Never put an irreversible, non-idempotent action in the same node as something that might randomly fail. That is all for this one. Thanks for listening and keep building.